Notification. I am recording this, so if you want to black yourself out or something like that, you can go ahead and do that at this time. I'd appreciate it if everybody would just note the slide number that you have a question about, so that you can ask that question at the end of the presentation, so that Clark can go through this presentation, and then we can get to question and answers. And with that, if you need to use the bathroom, you know where they are. They're in your own home. So appreciate you being here, Clark. Thank you for everything you've done for the last basically year and a half, and it's all yours.
Yeah. All right. Thank you, Barry. Thank you all. I'm excited. I'm a little disappointed that this is our final meeting to talk about the Lake Lawrence Cyanobacteria Management Plan. I want to spend most of this time with discussion and Q&A of next steps. You have the management plan. We've had lots of discussions around options. I know in your recent May meeting, there was a decision on the pathway you wanted to go forward. And so I wanted to help provide any guidance and have a good lengthy Q&A. But I'm going to start first with just a brief overview of how we got here. And then we can spend as much time as we like talking about next steps. And in case you don't know me, my name is Clark. I'm a limnologist or a lake scientist here with Herrera Environmental Consultants. We are a consultant firm of engineers, scientists, landscape architects, and planners on the Pacific Northwest, centered out of Seattle, with a dotting of offices in Bellingham and Portland, Oregon, which is where I'm at. Start blazing through this. If there's content you want to ask some questions around, we can pause there. But again, I really want to give you the most value for your time and have discussions of next steps. So Lake Lawrence is toxic algae blooms. You're well aware of this. It is on the impaired water body list put out by the Washington State Department of Ecology and approved by the Environmental Protection Agency, is listed for both harmful algae blooms and total phosphorus, which is the nutrient that is causing those and feeding those harmful algae blooms. This is a result of lake eutrophication, where we have increasing amount of nutrients coming into a lake over time. These can come from both natural and cultural sources. In Lake Lawrence, it's much more of a cultural source or human source that really accelerated the amount of phosphorus and nutrients that are entering the lake. We want lakes to be somewhat productive. That way they can support ecological diversity and fish productivity, if that's the desired use of the lake. But excessive amounts can result in these impacts to ecosystems as well as human activities due to these toxic effects, or essentially creating these monocrops of algae that dominate other types, which kind of shifts in the whole food web. We classify lakes in terms of trophic state, which is just how productive a lake is, how much algae is blooming. These are hypereutrophic, which is pea green, eutrophic, mesotrophic, and oligotrophic. Oligotrophic lakes are those you would see typically up in alpine areas. And we look at these by looking at the phosphorus, chlorophyll A, which is a measure amount of primary productivity within these algae cells, and then Secchi depth, which is a measure of how clear the water is. Lake Lawrence is eutrophic. Sometimes it's dipped down to mesotrophic, but typically it is eutrophic. As you're looking at this, the trophic state index is going from oligotrophic to hypereutrophic. So as the index goes up, as that value gets higher, we're seeing more productivity. And that's what we've seen sort of over the since about 2008, with Thurston County monitoring as a slight steady increase. There's a handful of data from previous years in 1990 during the KCM study, and in 1997 some ecology studies, but it's really hard to compare between these, and there's been a lot of different method changes within labs, so it's not always apples and apples to compare these. There was a bit of a little dip in the recent years, but we're seeing in 2025 still high amounts of chlorophyll and phosphorus and low clarity, and continue to see these algae blooms. So where is all this phosphorus coming from? You're well aware about the past diversion of the Deschutes River. That brought in a lot of nutrient-rich, phosphorus-rich sediments from recently logged areas, which then all settled at the lake bottom. So we brought in a whole lot of nutrients, and then after removing that diversion, the lake didn't really flush as much, so it really has just continued to concentrate, and that phosphorus that's come to the lake doesn't have much opportunity to be exported over the weir or via groundwater. We developed a phosphorus budget, which is accounting for how much phosphorus is coming into the lake and how much is leaving the lake. This really highlights that cycle where we have all that nutrient-rich sediments at the bottom of Lake Lawrence, and it accounts for 80% of the total amount of phosphorus that's coming into the lake. And then most of it is staying within the lake, is falling into the sediments. And so we just have this positive feedback loop where nutrients are continuing to accumulate, phosphorus is continuing to accumulate within the sediments. So where is that phosphorus coming from? So we have nutrients and organic matter are settling and accumulating within the lake sediments. Phosphorus is released during the decay of that organic material. Some of it may be bond to metals in the sediment. However, when there are low oxygen conditions within that sediment, iron and phosphorus complexes break down. The iron is reduced chemically, and that can allow that phosphorus to be released, which is then used by cyanobacteria or blue-green algae. So that's why we developed this lake cyanobacteria management plan, to develop a science-based comprehensive plan to guide investments in the lake to benefit human recreation and environmental health within Lake Lawrence. This is focusing on surface water quality, not necessarily fisheries, aquatic plants, drinking or groundwater quality, or flooding issues. When we've looked at this, we want to think about co-benefits or consequences, but our primary focus has been how to manage cyanobacteria within Lake Lawrence. You now have the 652-page report. It goes through the background of the lake, its history, its use, what are the current and future or current and historic management actions, setting goals, objectives, and success measures, summarizing the findings and the modeling, developing recommended management actions, providing an adaptive management framework. And then we have a lot of appendices, and that's where a lot of the length of this report is. And so my hope is that, within the main document, within the executive summary, and then if you want to look at the entirety of it, which is, I think, about 60 pages, it's a lot more digestible than the other 90%. But in Appendix A, we have the water quality report, as well as the development of those budgets, documenting our process of how we estimated that amount of release from the sediments, how we estimated how much was coming from groundwater, how we estimated what was going over the weir, leaving the lake, all of that. And then we have, Barry spoke to, hundreds of pages of laboratory reports. Really want to provide the source of information, the source of truth that's underlying this. I've gone through a lot of past reports, historic reports, and I've always wanted to see what is underlying data and make sure I believe their conclusions. So we want to provide that for you all and generations down the line. Appendix C dives deep into different management methods, as well as our development of planning level cost estimates. Appendix D defines additional funding options. And then in Appendix C, we have a bunch of definitions in our glossary. So our objectives are, after management actions are implemented for a given 5-year period, to have no more than 1 year with more than 2 plume events, and to have no year with a bloom that's lasting more than 3 weeks. And this is a bloom as defined by a warning or danger sign posted by public health, or microcystin or antitoxin or other cyanotoxin concentrations above the recreational guidelines. We also want to maintain Lake Lawrence at a mesotrophic state, so moderately productive, with these specific metrics in mind. So improving light clarity and decreasing the amount of algae within the lake. So to manage algae, we need to control phosphorus, and really thinking about inactivating phosphorus, keeping it locked away in the sediments. So we looked at a whole host of options here, defining what was feasible and what was infeasible. Focusing on these feasible actions, we looked at both oxygenation of the hypolimnion, of the deep waters of the lake, in order to keep that iron to phosphorus bond contained, or to look at amendment with phosphorus inactivation chemicals like alum, lanthanum, or additional iron. We also looked at proprietary chemicals like CDOX Max and Utrosorb WC, but those are much more expensive and they require additional permitting hurdles. So those actually could be moved over to infeasible. I'm not going to go through all of these management actions. I'm happy to jump over to them, but we've discussed them a lot. They're well discussed within the report. But essentially, we had 3 alternatives you're looking at. One is a high dose, which is much more expensive upfront, designed to last for 10 plus years. Option B is to spread out those treatments over multiple lower doses. And option C is a hypolimnic oxygenation, which is an upfront capital investment for this system with ongoing O&M, but also will provide long-lasting benefits in addition to looking to sequester the phosphorus. It also deepens the amount of habitable area for cold water fish like trout. Some photos of these treatments. There's a lanthanum treatment of Long Lake in 2023. The alum reset treatment in Green Lake has occurred 1991, 2004, and 2016. And I've been talking with them, and we're getting set up to do another treatment in 2027. So again, about in every 10 years for Green Lake. Kitsap Lake, Bremerton does annual Utrosorb G treatments, which is lanthanum modified bentonite clay, and Lake Stevens is on annual alum treatments. We also are looking at zero valent iron. This is a more novel technique here in the Pacific Northwest that has a greater amount of uncertainty compared to alum or lanthanum. There is suggestion in some scientific literature that by putting even more iron into the lake sediments and saturating them with iron, even with the low oxygen levels, you can have formation of redox or of metal crystals, vivianite, that are resilient to that oxygen impacts. And so by pouring more and more iron into it, those crystals have more opportunity to form rather than the current status of the amount of iron in the sediments. This has been tested in mesocosms and in lab studies, but not necessarily at an entire lake scale, and not in the Pacific Northwest, with clear data that shows success. The oxygenation system, example we're looking at is the oxygen saturation technology developed by Dr. Paul Ganser. Looks to pump hypersaturated, supersaturated water with oxygen deep into the lake bottom that's actually able to penetrate the lake sediments. It doesn't bubble up, it just oxygenates that bottom waters as well as the sediments, therefore keeping iron in that oxygenated state and bonded to phosphorus. The approach that was selected by the Lake Lawrence Management District at the May 14th meeting was to conduct a zero-valent iron treatment in the near term with an approximate dosage at half of the sediment phosphorus within Lake Lawrence. I made updates within the Lake Management Plan for the change in dosage. And so estimated that dosage would be $170,000 for treatment, including monitoring. Those costs and dose may change based on the selected product or particle sites being used, and that's something we can talk about more, Barry, I'm sure.
Yeah.
And then to work towards securing funding for an oxygenation system over the next 5 years. The approximate cost for that are $220,000 for design and permitting, which would take 1 to 2 years after having that funding. $2.2 million for installation, likely higher in 5 years, considering where we are for inflation. And then once it is operating, $22,000 per year, approximately for electricity and other maintenance. With the caveat here that if ZVI treatment is not effective, by looking at this monitoring data collected by Thurston County, especially looking at that deep water hypolimnetic concentrations of phosphorus, if we're not seeing a decrease there or a significant decrease, switching over to use alum or lanthanum, targeting a 25% of the sediment phosphorus with the treatment. Because it is a lower dose, there wouldn't need to be a buffer for the alum treatment, which allows it to be less expensive, but it would still be under $67,000 for that treatment. And lanthanum is about twice that amount. Thinking about how this is going to be funded, those are a lot of dollar signs. There's money that's available through your district rates as allocated by you, the steering committee, and the whole of the Lake Management District. The other sources are Thurston County budget allocations, which is not likely. This is not really a time where folks or local governments are spending additional money. Same with the state legislative budget allocations. I've been talking with a state senator recently, and she told me to stay away from any legislation that has a fiscal note. The freshwater algae control grants are a great source, and this is right in line with the goals of those grants, but it is capped at $50,000, which is going to be helpful and is useful. Those costs to keep up with inflation, that grant amount, but that might be several years down the line. There's also the state revolving funds for loans. Based off of what I've understand from Barry, the county is not currently willing to act as a loan administrator on behalf of the management district. I would hope that might change over time, but what we see, we are where we are. So that's not something that is we want to put on our front burner for an avenue for funding. Centennial grants and Section 319 grants currently exclude in-lake treatment, which would include iron, lanthanum, alum, and oxygenation systems. I am currently working with the Department of Ecology as well as the EPA to change those elements and that exclusion. I think there are a lot of very special cases where watershed actions, despite all the best intentions, won't do anything for in-lake water quality due to historic pollution that has occurred. And we have the very convincing argument. We're just moving through state and federal government processes for that. So I'm hopeful that might be available when we're thinking about an oxygenation system in half a decade. I didn't talk too much about watershed source control here, but a clear thing to consider within Lake Lawrence are septic systems. Human wastewater is rich with nutrients, and most septic systems are unable to treat phosphorus. They rely on the surrounding soils to bind to that phosphorus and capture it. At some point, those soils become saturated and can continue to leach into groundwater, which then can be entering the lake. So an important thing to do is one, to make sure your septic systems are not failing, keeping with annual or triennial every 3-year inspections as depending on the design, and then making repairs as needed. Craft 3 is a great program that provides financial assistance for septic system repair. So now we can really get into Q&A. These are my sort of recommended next steps as we are looking to do this pilot treatment with zero valent iron. First is to develop a specific treatment plan for the sediment phosphorus sequestration. What we have developed within this lake cyanobacteria management plan is planning level, a great way of comparing between all these different products and all these different management actions. For actually moving forward with specific sort of treatment, we do recommend collecting additional sediment cores to help refine doses and treatment areas. Right now we have are basing sediment treatment rates based off of 3 sediment cores that were collected in the Big Basin and 1 that was collected in the West Basin. So by collecting additional cores, you can look to see what that variety of phosphorus is throughout the lake and right size the dosing. That's optional. We can rely on the existing data. We just have more uncertainty in terms of, are we maybe applying too much in certain areas and not enough in others. So additional is for ZVIs, determine the specific particle size. That can be done as part of the specific treatment plan, or that can be punted into the applicator as something they would bring forward when they are putting together a bid based off of their experience and their best professional judgment of what products they would like to use. There is not a huge amount of literature in terms of right sizing the zero valent iron particle size. There are lots of different varieties. Within HEPURE itself, they have the Ferox PRB, permeable reactive barrier at 325. They have Ferox Flow, which is 120 micrometers, and then Ferox Target, which is, I think, about 50 microns. So really small. These are all very small. So like a micron itself is 1/1000th of a millimeter. Then determining who's going to obtain the permit, conduct monitoring, complete notifications as required by the permit, and how contractor oversight will be done. I really want to note here, and you probably are aware of this, but I need to stress that the aquatic plant and algae management permit areas where treatment occurs cannot overlap between multiple permits. So if you have a APAM permit for treating Lake Lawrence for aquatic invasives, the applicator, either that applicator needs to be the same person who is doing the phosphorus sequestration treatment, or they need to transfer that permit to the applicator, or that needs to be transferred to the county, and then they are hiring the contractors. It is very frustrating in many cases because most of that aquatic plant treatment is happening around the shorelines. Make sure that that is a separate permit. There's an aquatic plant treatment permit, and then we have the phosphorus sequestration permit in the deeper portions, below deeper than 5 feet for the lake. So just something that needs to be planned out ahead, and some coordination has to occur between ecology and existing permittees.
The county has our permit, Clark, and
they hold the permit.
The county holds the permit for both phosphorus mitigation and for vegetation control.
Okay.
So it won't require a new permit, and the county is the one that will approve the contract, and the Board of County Commissioners will approve the contract at a regular Board of County Commissioners session after the RFP is done and the selection is made.
Great. That makes it a lot easier. Because in some lakes, the applicator is actually the permit holder. Right. So this is much easier setting.
Yeah.
And then there needs to be a development of the bid with treatment specifications, identifying what are the minimum qualifications for applicators, providing some background on the project, and then providing details on how that treatment is expected to occur. For dosing, this can be very prescriptive or can be flexible. For example, you could develop the bid to be targeted based on, we have this much phosphorus within sediments we want you to target, and we want you to use 0-valent iron. Tell us how you would like to approach this problem. Or it can be based on, we have a very specific product or particle size in mind and a certain amount of pounds that are expected to be used. So that's something that can be developed during that treatment plan, or relying on the sampling data that we have, identifying certain treatment areas for phosphorus with certain concentrations to be sequestered.
Yeah, we're going to, like we've talked about, we're going to target 5 feet and below.
Selecting that contractor with the county. No need to transfer the APAM permit, thankfully. And then ensuring those permit requirements are met, doing the necessary pre-notifications to folks living near the treatment area, conducting monitoring both before and after, during and after, reporting that to ecology, and then being on the lake, conducting contractor oversight to ensure that treatment is occurring as planned, that the product that is being used is matching the product that's in the bid, making sure the application is happening at the rates expected, just checking in daily as it's occurring. And then finally, after all this finally happened, is to look at that data for Lake Lawrence and evaluate whether or not water quality outcomes are being met or are improving based off this treatment, especially looking at that deep water phosphorus levels, and then adaptively managing if needed. I have like something on my project schedule, a slide on this, and that's saying it's done. We've made it. I have time for Q&A, and then happy to talk more about the iron particle size and what information I've found around that, and hear what information you have there and others, but also, questions from anybody.
Okay, could you go back to slide 15?
Yeah.
Okay, so option C, hypomagnetic oxygenation. Next slide. Next slide. Next slide. Next slide. No, there's one here. Okay. So I had a call with Brianne Blackburn, Pierce County today. Reference the system they're putting in at Spanaway Lake. That project has been delayed a year because they identified another problem that has to be resolved before they can do the infrastructure. And that is that the compressor and the system inside the building that's on land creates a whole lot of condensation, up to 1 to 2 gallons an hour when it's operating. And they did not engineer a drain in the building. And they also found that because it is a system that goes through a process, that the condensation that's coming out cannot be just dumped into a drain field. It has to be put into a sewer or septic system. So they're going to have to hook up to a sewer system because of NPDES discharge requirement. As I've said in my briefings to the steering committee and to our county commissioners, it's emerging technology. That's what I look at it as emerging technology. It's the best type of emerging technology that deals with, what they call, I guess, lake physical methods. Putting oxygen in. All the others really don't work. They're not effective at all, or the effectiveness is not known. But I guess next time you talk to Paul Ganser, you might talk to him about, okay, what are you guys doing to fix these problems that have arisen? Are you actually taking on those problems and trying to fix them or not? Because that's going to be our questions.
I appreciate that. The challenges of hypothalamic oxygenation and has led to, one, this innovation, but also a lot of very good hesitation around their use. The benefit of this is it is built to be more durable as well as easier to maintain through its high density plastic structure, as well as ability to have these adjustable floats. That said, they are still, in their early phases of implementation across the U.S. And so continuing to watch those. I know there's a pilot effort currently happening in Canada. And so I appreciate the hesitation as well as the let's wait and see how this works in Spanaway, as well as these other areas.
And that's what we intend to do.
I'm sad to hear about the delay at Spanaway. That issue of condensation was not presented or known by our engineers. So
it was not known by when they did the design, and they were almost completed with the design. When they discovered the issue.
Yeah.
So could you go to next slide 20, I think it is. Okay, so our costs are about 2.7 mil is what we are looking at for OST system. There's another group of money in there, about $200K for another portion of infrastructure costs that are not shown here. I just want to point that out. But we're looking at about 2.7 million, and I've taken a look at the specs and the specifications for the 90% design at Spanaway Lake, and a lot of that would pertain to us with any changes that they make. But our infrastructure costs are going to be much more expensive. Frank, who's on this call, has already done some legwork for running electrical lines, three-phase and single-phase to the two different locations. And it's pretty spendy. It's over $100,000 at one location, isn't it, Frank?
Yeah, for the three-phase, $100,000.
Yeah.
Not priced out the single phase, but it's available and pretty close to the lake if we put it at the park.
Yeah.
Okay.
So that's one of the challenges for us. The particle size for ZVI is something that I've really been looking at closely. Between the 40 micron, the 125 micron, and the 325 micron. And still got some more legwork to do on that before we actually submit the RFP.
Most of the phosphorus that we see in Lake Lawrence is not in that dissolved state. So those finer portions are really only going to be that fine ZVI.
Yeah.
It's really just able to bind to dissolved phosphorus
right.
as it's coming through the water column and then landing on the sediments. What we're really interested in is maintaining that barrier of iron or alum or lanthanum at the sediment interface to capture the amount of phosphorus that we're looking to capture, or the amount of phosphorus that's in Lake Lawrence. There's about 3 kilograms within the water column and thousands within the sediments.
Next slide. Yeah, I think you covered this pretty well. Next slide. I think we've already talked about this. The county holds the permit. County commissioners will approve the contract after we do the RFP and the review and selection. Okay, let me turn it over to others that have any questions. Wow. I've never heard silence at a meeting I've been to.
No.
I guess I'm just going to verify what I think I read in your report on the ZVI, that we would do, you referred to it as a pilot project, and so we'd be, putting in the ZVI in year one, and then after 3 years, we're going to have been doing all of this testing and trying to determine if it's effective. And then you suggested that in year 5 to 10 or year 6, we would do the second dosing. Is there any magic about waiting until year 6? Is that just a guesstimate? And also, you, I believe, suggested in year 1 that we're doing a 50% dose on the whole lake. Is that because it's a good amount to do this pilot test?
Yes. So thinking about the 50% dosage, this was through some conversations I've had with Barry. Initially I was looking at 10% annual doses, but I was given guidance we were looking for larger doses, 25% doses for alum and lanthanum, and then for ZVI, given its lower cost, trying to cover more ground with it. And to be clear, when we're talking about these 50% doses, we're not saying we're treating half the lake, we're treating half the amount of phosphorus that's in the sediment. So it'd still be getting applied to the entirety of the lake, or at least especially in the big basin. That's where we see most of the phosphorus being released. So to target that, and that's what that was built around, because as you'll see, a 50% ZVI treatment is about the same cost as a 25% alum treatment. And then in terms of why are we waiting till year 6 and not doing it sooner, is to make sure it's going to be a good investment to do, and really looking at that years, or really 4 years of monitoring data to see, do we see a notable amount less phosphorus in those deep waters? Was this 50% dose effective? Should we finish it out? However, if an oxygenation system is being funded and is being put in, that might be not necessarily the investment you want to make is in the ZVI, but rather to put that $200,000 some towards the oxygenation system. But that is in 5 years, and we'll have a better sense of whether the steering committee has faith and confidence in that technology, or because there's just a lot of unknown. So it's just like, in 5 years, really think about what do you want to do next.
Yeah, because we're going to be continuing to monitor SRP in the lake every 3 months. Is what I've got it planned for, so that we can see what we're doing, how it's coming along, and if we need to apply more, then we can earlier. That's why we've got it in our plan for years 2 and 3, with the sediment core samples again in year 5. So,
Great.
Okay, Frank.
Thank you.
Just really quick, you guys heard any complaints on rust?
I have not heard direct complaints around rust, nor have I spent much time talking with folks who have lived around a lake that is iron treated. I mean, there's Lake Steilacoom, Lake Lorraine, have all been treated.
They'd complain about it if there was. I just wanted.
I would think we would hear about them. So
yeah. All right.
Yeah, and again, I think keeping it away from the shallow areas. The more shallow parts of the lake have the most turbulence, whether from boat props, or from wind itself, and so that getting kicked up would cause more concern. And that's the same for alum as well. That's why we don't really apply alum or lanthanum or any product, close to the shoreline. Try to keep it deeper where it's going to stay there.
Clark, I don't know if anybody else got any other questions before I ask you this.
Sure.
Okay, so you got my email about the test equipment we're looking at?
Yeah.
So what is your recommendations on that? I mean, I categorized it as better, best, and good.
So some of these I have not used the Hana San, so I cannot speak to its quality. I am most familiar with Hana as a laptop or within the laboratory instruments. I've not seen them in terms of out in the field. That's not to say it doesn't work well. I just don't have experience with that. I don't know anyone who does.
Yeah.
I expect that it would be suitable for your needs, and I would just want to make sure that it's under a good long warranty, like 3 years, just for that. And I don't want to recommend something that I don't have experience with, but I also don't want to say don't do it.
My question more was not about the quality of the product. I've checked the reviews on everything, but more so with does it meet the testing parameters of ecology?
Oh, yes. So for ecology, for these profiles for monitoring,
right?
They do not look specifically at what instrument you're using, rather just to make sure that they're calibrated before and after, and they're meeting those quality objectives. So before going out and sampling, doing a pH check using buffers at 4 and 7 and 10, and then when you get back, doing a check as well, and making sure that they're at 4, 7, and 10, those buffers after you've gone on the field. So just doing that before and after measurements, and if it stays within certain objectives, usually we say plus or minus 0.2 for pH, plus or minus 3% for dissolved oxygen. Setting those up will be great.
What other questions do you folks have? I can't figure out how to unhide myself, so you can't see me. I'm not careful, I'll mute myself and I won't even be able to talk to you.
Barry, are we thinking about, I think during the presentation, there was this option of testing additional sediments so that we know how to apply the ZVI in a more precise way. Are we going to be doing that, or have we decided?
We haven't decided, but I'm not inclined to do it initially for the first 2 years anyway. I've talked to Clark about this, and frankly, we talked about several things about, whether we would want to do additional testing at the cost that it would cost us, or just see if it works.
Oh, I see. I remember that comment earlier in the previous meeting. Okay.
Right. So,
yeah, the testing after we've applied it will give us the same information as sediment testing. So,
well, if we do
right.
core samples,
the dose we're looking at, if it is effective, we would expect to see an impact, even if there is some variability across the lake. We would still see this. I think from the sediment samples we've collected, we have a pretty good sense of where it's highest.
Yeah.
It's really kind of helpful for us determining, like, oh, maybe we can do less in this area, because what we're starting with is the deepest part of the lake, and that's where all the nutrients and algae really start to attenuate and focus into, is the deepest area. So that's going to be sort of the highest concentrations, and we see that for the big basin. West Basin has lower concentrations, but so if we're using the big basin to help drive most of the treatment, we expect to see that. It's really to help us decrease the cost of the treatment. Let's see, recently we did some sediment sampling. So we developed the Blackman's Lake cyanobacteria management plan. They wanted to move forward with alum treatment. We did, and that alum treatment cost about $4,000. Before they made that investment, we did go out and collect additional sediment samples, as well as like developing that monitoring plan and doing the analysis. And then we helped them develop that treatment plan. And that total cost of that effort on our side was $25,000. So it is a bit of an upfront investment, which I think makes a lot of sense for a $4,000 investment. For the ZVI at 170, it'd still be something worth considering.
also, you're talking about 325 microns PRB Ferox versus 40 or 125. With 325, that wouldn't be a slurry as you would with a powder.
So with the 325, again, I think that it still is at 1/100th of an inch. So that still can be applied as a slurry. I've seen it applied as a slurry, is my understanding.
Okay.
Because the 100 micron or 150, not the target,
you've got
the middle one. That's it's 100 versus 300, but it's just a third of the size.
Yeah, you've got Ferox flow at 125 and Ferox target at 40, and the PRB is at 325. So,
I have another question. So a lot of these numbers go beyond me, but we've talked about something we recently talked about was being between 0 and 50 to 100. My question is this. The phosphorus that's in our lake, I believe, changes depending where you are in the lake, the season, the timing, maybe even time of day or part of lake. So when we've applied the CVI and we're doing our subsequent testing, we're going to get different amounts. Are we just doing averages then compared to what your study said to see if we have less phosphorus over a period of time and over different parts of the lake? Is that the process?
Yes, that's a really good question and note, is that there is variability over time, over depths, between different locations. And so what we would be looking at is that average. Typically, as we're looking at, and especially in this case, we're looking at effectiveness, I'd be really targeting and looking at that deep water concentration. I would notice peaks. I'd be interested in see if there was a big peak that occurred, and that'll get captured in the average. But also you want to think about is that just an outlier? Because we do see, in the historic data, there are other big peaks that occur. And so there's some years that just have much higher concentrations, but nothing really was that different that year. There's just noise that occurs within the environment. By doing the monthly sampling that Thurston County does, we have a lot more confidence in being able to capture more of that noise and have a better estimate with our average. Some sampling regimes are just going out once per year, and has a lot more uncertainty with it. And yeah, so yes, really looking at that average over time within at the deep levels, and really what we were hoping to see would be a very noticeable decline by 50% or more. So that's a pretty big, statistically, what we call an effect size. And so with that amount of change, we don't need that much data to have confidence, that many samples to determine, yes, wow, we did it, or we didn't.
Yeah, and for us, Janice, we'll be doing the basic testing required by ecology along with SRP every 3 months. That's what I've got in the plan that I'll put forward to the committee in July and for the budget purposes. But the county will also be doing the total phosphorus testing, and we'll get those results as well. That's why we're not doing total phosphorus testing and those other things, because the county's going to be doing those anyway.
Okay, good.
So, okay. Any other questions? Clark, I appreciate your help and time and effort. And I know this isn't the last time we'll be talking, because we've got RCW 3661 coming up next month, right?
Oh, yeah. I'm excited.
Okay. No further questions, guys. We're going to let Clark go. And thank you.
I'm impressed. All right. Thank you all so much. Have a great evening.
You too.